Welcome back, folks. In today's class, I'm going to talk about Newton's third law. Newton's third law. So Newton's third law says that every action has an equal and opposite reaction. So if I'm going to hit you, so for example, this is me, I'm going to hit you with 50 Newton force. You're going to hit me back with the 50 Newton force. So that was on just a lighter note. So, but in reality also, if this is a wall and I'm going to punch this wall with certain amount of force, so I'm going to feel that force also, because let's say if I hit it with 100 Newton force, I'm going to feel that force also. That is in accordance with the Newton's third law, and that's how we walk also. So if we put the pressure when we start walking, if I'm gonna put the pressure down on the ground of whatever Newton, so let's say 10 Newton force I apply, the 10 Newton force will be applied by the ground back on me. So that is in accordance with the Newton's third law. Now, based on this concept, I'm going to take a problem, and then we're going to talk about some concepts which we will be using to solve the math problem. So I'm going to take a problem example 3.3.12 from Pearson book for grade 12 physics in Alberta. So in that example, there are three boxes. I'm gonna iterate the example for you guys here also. So there are three boxes given to me, and the mass of the box A is 8 kg, and the mass of the box B is that is 10 kg, and then there is a box C also, which is 5 kg. And imagine there is a frictionless surface, so there is no friction which is being applied in the opposite direction, no force of friction, no force of friction in this case. All right. And we are also given that all these three boxes accelerate with the force of 1 point with the acceleration of 1.5 meters per second square. And this is me who is pushing against these blocks, and these blocks are moving with an acceleration of 1.5 meters per second square. I wanted to calculate the force exerted by box C on box B. So this is what I wanted to find. How much force box C will apply back on box B? So how are we going to solve this question? Is I am trying to find the force exerted by B on C. Although I'm applying the force here, so I won't consider force applied by me on all these three boxes. What I'm going to do is I'm going to only draw the diagram for box C, and I'm going to imagine this is me. I'm pushing this box, and then how much force will be applied back on me because I'm applying certain force on box C. So I will write the equation now for the net force. F net value will be equal to force applied minus force of friction. And what did I say in the beginning of the question? That there is no force of friction in this case. So if there is no force of friction, I'm going to cancel this one out. And force applied, that's what I wanted to find out. And I am applying this force on this box C. So the net force is ma, and mass of the box which is equal to this box has a mass of 5 kg, and then acceleration is 1.5, and that will be equal to force applied. So I'm applying how much? 7.5 Newton of force on the box C, and same amount of force will be applied back on me. So force applied by C on B will be equal to, oops, I can't write it, 7.5 newtons in the opposite direction, in this direction, backwards, you can call it, or to the left. All right, so I'm going to extend on this question. So if, let's say, out of these three boxes, same three boxes given to me, and now in this case I wanted to find out how much force is being applied by A on B. So I'm going to remove this A, and I'm going to place myself. Earlier I was here, now I'm going to say this is me, and I'm applying the force on box B and also on box C. This is B and C. So how much force I am applying on these two boxes? First of all, that's what I wanted to find out. So force applied minus force of friction which is equal to net force. Now, force of friction in this case is 0. So force applied is, that's what I wanted to find out. Now, what is the mass I'm going to consider? Because I am not only pushing the box B, I'm also pushing this time around box C, because that's in front of the box B, which is also causing the obstruction. So I'll consider the total mass. This was 10 kg and this one was 5 kg. I'm taking these masses from the previous question. So 10 kg and 5 kg. All right, so now that will be 20, well, it will be 15 kgs, 15 times 1.15 times, it will be 1.5, which is approximately force applied value will be equal to 23 newtons. So that's how you're gonna solve these questions. So another thing I want to tell you, if there is some sort of a force of friction also given to me, then I will encompass that force of friction here also. That's why I intentionally put it here. In the book, they haven't used this force of friction so that you don't confuse. This is the complete formula whenever you're solving the questions for Newton's third law. All right. So example 3.13, that's what they've tried to do, in which you are also given the force of friction. So try and do those questions, and yeah, let me know if you have any questions. Hopefully you were able to understand this. I will see you in another video. Till then, goodbye.